Hi everyone, welcome to this week's lecture, which is all about survey design. Now, today's lecture is going to be really interesting because we're going to focus on how to design a survey, as noted by the title. But in addition to that, some of the pitfalls that you may see when designing a survey or even when you're doing a survey, and how you can sort of mitigate against some of those biases in the procedure. So we'll go through each of these sections, but before we do that, we're going to do a quick recap. So last week, what we were focusing on was the types of research that there were. We covered experimental, quasi-experimental, and non-experimental. So hopefully in your mind, as I'm talking through these words, you have some clear ideas as to their main features, but if not, that's why we do a recap. So the first one is experimental, right? So this is where you have random allocation of people to groups, right? Often very common in drug designs where they want to test the outcomes and efficacy of a new drug. So they'll have people randomly allocated to either have the drug, be in the placebo group, or be in the no drug group. The placebo group is a group that receives what they think is a drug, but is actually not the drug. And this is for a whole host of reasons. And in essence, you want to ensure that the effect is actually attributable to the drug itself and not through to other mechanisms, including being administered something versus not, or the time you have with the doctor, or even thinking that you're experiencing an effect. So these are all the features of what you see in a experimental type research. And particularly, this is what we call a randomized control trial. So this is where people are randomly allocated to groups. Why is this such an important feature of experimental design? Because it allows us to get as close to causality as possible. We can say the effects that we observe are due to the administration of the drug. And the random allocation of people to groups is what allows us to say with a certain degree of confidence that the effect is due to the drug and not due to extraneous variables. So that's really the critical takeaway when it comes to experimental design. So what you should be thinking of when you hear experimental research or trying to identify whether it's experimental is there a random allocation of people to groups? Yeah. All right. Excellent. So that's experimental. The next one is quasi-experimental. And this is where there are still groups, but there's no random allocation. You just use naturally occurring groups that are there. So you could say, in a group of people, how many people smoke versus don't smoke, and then you can see how what the effects are on some outcome measure. Now, hopefully you can see already why this can be a useful mechanism for research, particularly in the example I just gave you in terms of smoking, right? It's not necessarily ethical to randomly allocate people to groups and administer some groups with a carcinogen, which is cigarette smoking, and others not, and see what the effects are on some outcome variables. So there's ethics involved in that. So one way you can address this is by observing people in their naturally occurring groups. So this is useful. There's no random allocation that's occurring, and the challenge, however, is that you're a bit more likely to be confounded by extraneous variables. And what I mean by this is, how do we know that the effect that we see in the outcome, say in this case, it's running a marathon, right? So how do we know that the outcome is actually attributable to the people who smoke versus don't smoke? How do we know it's related to that versus just the naturally occurring behaviors of the people in those groups that may lead to those behaviors? So for example, maybe we do this study where we look at people who smoke and don't smoke and see if they can, how many of them have done a marathon, and we find that those who don't smoke are more likely to have done a marathon than those that do smoke. And then we say, okay, so perhaps there's a relationship here, and maybe the more that you smoke, the less likely it is that you're to do a marathon. And it could be that that's the case and makes mechanistically some sense, in the sense that smoking can negatively impact your lung capacity and cardiovascular output, and so maybe that makes it a bit more challenging. However, it could also be that the people who are more likely to do marathons are less likely to smoke, or maybe there's some other variable or confounding factor that's contributing to both of those things. And so maybe there's a certain type of person who does a marathon, maybe they're a bit more health conscious, and so they're less likely to smoke, but they're less likely to do other things as well. And so this is what is contributing to the effect rather than the smoking itself. And so we can't say smoking, if you smoke, that's what's going to lead to whether or not you do a marathon. It could be these extraneous variables. And so, whereas in a randomized controlled trial, that's certainly where that allocation could occur. So we have less control in a quasi-experimental. We're using naturally occurring groups, so it's a little bit more efficient as well in terms of resource intensive, but there is that vulnerability to extraneous variables. Now, when I say that, I should emphasize that these are design features, but the beauty of statistics is that we can, in fact, aim to control for some of these factors. We can control for variables that we think influence the relationship, and that's what we're going to cover in parts of this course as well in terms of multiple linear regression analyses. So I won't get too far ahead. We're just in survey design at the moment, but something to keep in mind in terms of how we design our surveys actually flows on to the statistics that we use. And then, of course, non-experimental research, which is where you're more interested in the descriptive nature of groups. So you may be interested to see how many people in the class run. You could even just say that, it doesn't have to be a marathon. How many people run at least twice a week? And then you get a descriptive nature. So there's no random allocation occurring. You're not using naturally occurring groups. You're just sort of getting a sense of there's no real experiment. So it's in the design as indicated by the word. So those are the three key types of research. Hopefully that's embedded in your mind now that you understand those three types. Okay, excellent. So I gave you an example in the last lecture about what is the effect of pet ownership on happiness. And think about a way to design and test this research question using each of the different types of research that we had above. So if we look at that question in terms of pet ownership on happiness, how does it match on to each of these three? So hopefully you had a crack at this yourself. If not, you can pause the video now and then take a bit of time, have a think, how would you design the study in each of these contexts? Assuming you've paused the video and now you've rejoined, or you already did the homework, good on you. So the experimental design, again, the key feature is random allocation. So you have people, and for some of them, you give them a pet, maybe a dog, and then others, they don't have a pet. And you see you administer a survey on happiness, and you see what the outcome is across maybe multiple time points at baseline. Week 1, week 3, week 6, maybe further down the track as well. And we can see what is the effect of pet ownership on happiness over time. Then there's the quasi-experimental design, where you could just ask people, do you own a pet? And then have them conduct the survey and to see whether there is a relationship between those variables in terms of pet ownership and happiness. And then finally, non-experimental, which is the more descriptive side of things. So you have a sense of how many people own pets and what the general happiness scale is of those people. And so that's just describing the research. So those are sort of the key ways in which that question can apply for each of those groups or designs of research. Excellent. So hopefully you have a good sense of those three types of designs. Really, really important, again, in not only in terms of how they're conducted, but also the fact that it flows on to many of the statistics that we do. And so we were talking a lot about the purposes of research as well. So we said that there's information gathering or theory testing can be thought of as the two main categories. And so you do that in a exploratory or descriptive manner for information gathering. So you may have no idea about what's going on in a phenomenon. Say I have no idea what is the relationship between or the factors that contribute to whether or not people watch these lectures. Yeah, I have no clue. And so I go and I just start exploring the sample pool. So I explore all the students at UC and I say, are you watching your lectures? And if so, what are the factors that may contribute? And it may be descriptive as well, right? So in that process, I'm sort of describing some of the factors that may be present in terms of why people watch or don't watch. Definitely not for third year statistics. Everyone loves to watch their third year statistics videos. And then the theory testing, of course, right? So you have explanatory or predictive. So explanatory is where you have a sense of, oh, perhaps they can see that statistics is a really useful way of understanding the world, enhancing their critical thinking and understanding research. And so let me look at these factors and see if they're more predictive of the time people take to watch the video. So that's explanatory. Predictive is where you try to use the data that you have to predict whether something else will occur. So in much of my research, which is about dementia and looking at risk factors for brain health, typically I try to look at the relationship between these risk factors and brain health. And then sometimes we then look at, does that predict the time it takes for dementia? Like if you were more likely to engage in physical activity regularly or engage in social interaction or have regular sleep habits that are conducive to healthier sleep for yourself, then is that more likely to delay the onset of dementia? And we can actually predict the age of dementia as a function of this with some level of precision. So that's information gathering and theory testing, which is just about the purposes of research, right? So what is a survey? A survey is a standardized measuring instrument. Hopefully that is hammered home strongly to you. Why is it that important? I realize I'm asking you lots of questions, and this is a recorded video, so there's not really a response. But hopefully you're screaming back into the camera the fact that it's important because you need to be certain that the effects that you see are attributable to differences in the group and not actually in terms of how you're administering the survey. If it's not a standardized survey instrument or measuring instrument, then it can influence the outcomes that we see. So an example of this is if we're looking at something like happiness, right? And I ask you, how happy are you, right? There are different ways in which I can ask you that question. I can say, how happy are you? I can say, it's such a beautiful day. I mean, it's not a beautiful day at all. It's actually very overcast. But I could say, it's such a beautiful day. Are you feeling happy? Or there's so many things to be grateful for. Are you feeling happy? Or I could say, how happy do you feel today? Keeping in mind that all these other factors could be happening that aren't as good, and maybe you can be more grateful for your life, right? So in all these different sort of avenues, fundamentally, it asks the question of, are you happy? And you can even lead it in and say, you're happy, aren't you? Right? And again, that's a way in which all of those formats are asking the same question of, is someone happy? But in many of the different ways, I've tried to show some extreme examples as to how it can influence someone's response. They're like, oh, yeah, sure, I guess, yeah, actually, yeah, that makes sense. And so then then you have another experimenter who is doing the same study and not influencing it in these ways, and then you get differences in results. So they're not actually due to differences that you see in the samples, but rather differences as a function of the way the person's asking. So it's really, really important. Of course, when you have a survey, you administer it in the same way, but when you're doing an experiment, you're interacting with participants, you're trying to ensure you're being as standardized as possible in your approach. But when it comes to a survey, the survey is a standardized instrument for these reasons. And one of the most annoying things you'll find as someone who's been taking part in research is when there's a question which may not be well designed, it may not be clear enough, or maybe it's intentionally ambiguous for some reason. And you as a participant ask the question of, oh, can I have more information, or does this apply in this context, or do you mean in the last week or in the last few months, or what does this relate to? And the experimenter says, just do the best you can. Just fill it out the best you can. And the reason why they say this is because they can't give you any further instructions if they've already collected data from other people who haven't asked that question and haven't been given further instructions. So that's where the standardized stimulus comes in play. What are the pros? It's ecologically valid. Remember, that means that you're testing someone in their environment. So sometimes when we do a lot of lab experiments and you see how people act, an example could be perhaps a driving simulation experiment, and you're testing them in the lab, and then you see them out and about in a car. In the real world, it may not actually translate perfectly. And this is because in a controlled environment, there's differences that may happen. And this happens in a whole host of contexts. So ecological validity is really, really important, and surveys allow you to achieve that because you're able to give someone a survey in their own environment. Really cost efficient, particularly with computers. You can create a survey on a platform for free and send it out, and everyone can have access to it and do it. So it's really, really cost efficient, and you can obtain lots and lots of data, which can have a lot of utility, and we'll talk about that much later in this semester when we're talking about power and effect sizes. What are the cons of surveys? Well, often you'll see low compliance, and in terms of either starting the survey, or maybe they even just try the survey and work through it and then sort of drop off, so they don't even complete the survey. So that can be a challenge with survey research. And of course, the biggest challenge is it really relies on self-report, someone's own perceptions of how they're feeling, or their own measures. All of these factors rely on self-report. So those are the probably main limitations of survey research. Excellent. So today, what we're going to do, before we get into what we're going to do today, I'm going to pause the recording there. So have a break, take some time, stretch your legs, reflect on all the stuff that we learned last week, and get yourself ready for the excitement to come, which is about the research process and survey design. So I'll pause it there, and then we'll regroup in a moment.